There is a problem in astronomy that nobody has managed to solve in more than 75 years. If there are 2 trillion galaxies out there, shouldn't somebody besides us be sitting in one of them? And if somebody should, why has that somebody never once shown up? We fed those astronomical numbers from the sky into Axiom, an artificial intelligence built for analysis. And what it handed back about the silence of the universe is what I want to show you. Start with the simplest count there is. On a moonless night, far from city lights, the naked human eye picks out around 2,500 stars. The Yale Bright Star Catalog lists some 9,000 across the whole sky, and from a single spot on the planet, you get a little more than a quarter of that. Sounds like a lot. Our galaxy on its own, the Milky Way, holds between 100 and 400 billion stars. In 2016, Christopher Consulis and his team at the University of Nottingham published a survey that put the number of galaxies in the observable universe at around 2 trillion. Multiply those two numbers together, and you get a picture the mind cannot quite hold. For every grain of sand on every beach and in every desert on Earth, there are something like 10,000 stars in the universe we can observe. 10,000 suns per grain. Pick up a handful of sand and do the multiplication, and most of those stars have planets. In 2013, Eric Pettigura, Andrew Howard, and Jeffrey Marcy used data from the Kepler telescope and published a calculation in the Proceedings of the National Academy of Sciences that became a benchmark. Roughly 1 in every 5 stars, like the Sun, carries a rocky planet in the habitable zone, that band of distance where water can stay liquid. In round numbers, in the Milky Way alone, that comes to something close to 40 billion worlds with a shot at biology. In 1961, the radio astronomer Frank Drake put together a formula to estimate how many civilizations in our galaxy would be in any position to make contact and hold a conversation with us. The Drake equation pulls together the rate of star formation, the fraction of stars with planets, the odds of life catching on, the odds of it turning intelligent, and the stretch of time it spends broadcasting a signal. Fill the equation in with the gloomiest values you like, and you still end up with a high number. With the optimistic ones, the number gets absurdly higher. In the summer of 1950, the Italian physicist Enrico Fermi was having lunch with colleagues at the Los Alamos laboratory. The talk at the table was about flying saucers in the papers, and everybody was having a bit of a laugh. Fermi, who could run complicated numbers in his head faster than the others could run them on paper, went quiet in the middle of the joke and spent a while staring at the cafeteria wall. Then he asked, "Where is everybody?" What gives that question its weight is time. Data from the European Space Agency's Planck mission puts the age of the universe at 13,800,000,000 years, and our solar system is 4,600,000,000. Billions of other systems got going earlier, with all the head start that buys. 200 years ago, the fastest transport we had was a horse, and a letter took months to cross the ocean. Less than 70 years ago, we put a metal ball in orbit, and the world stopped to listen to it beep. Today, we land a robot on Mars. Now, picture that same curve running for 1,000,000 years. On our side, we have only been making real noise for the universe for about 100 years. The mathematician John von Neumann described machines able to copy themselves out of whatever material they find in front of them. Michael Hart picked the idea up in 1975, published it in the Journal of the Royal Astronomical Society, and showed what it does once you turn it loose in a galaxy. None of it calls for a warp drive or a wormhole, and none of it breaks relativity. A ship traveling at 10% of the speed of light reaches an empty system, spends 500 years mining asteroids and assembling 2 copies of itself, and those 2 set off for 2 fresh systems. Then it repeats and repeats. The Milky Way is 100,000 light years from end to end, and even at that tortoise pace, it is filled corner to corner inside a few million years. A few million years inside a universe that is already nearly 14 billion years old. If one single civilization had done this once in any corner, there would already be an automated base on our moon and a drone of theirs circling Saturn. There is nothing. Nobody has confirmed a single artificial signal. Nobody has turned up a single artifact, and every anomaly in the sky is still explained by ordinary physics. The reading flips over when you put those two things side by side. The sky is not like this because nobody was ever born. It is like this because space today for us is best compared to a graveyard, and every graveyard has headstones. Every headstone carries a cause of death. The cause of death has had a name since the end of the 90s. The man who named it was Robin Hanson, an American economist at George Mason University, in a short essay that cost half of astrophysics a good night's sleep. He called it the Great Filter. And the reasoning goes that in a graveyard that size, most of the headstones carry the same cause written on them. Look at evolution as a staircase. Every step is a leap you have to make, and whoever fails to climb stays down at the bottom forever. The first is forming a star system with a rocky planet, liquid water, and carbon chemistry. The second is that instant when dead substances organize themselves into a molecule capable of copying itself. Then comes the simple cell, and then the cell with the nucleus, and then creatures built out of many cells. On the 8th step stands us, cities on the ground and telescopes pointed up. The 9th is the move out to other stars, and nobody in the observable universe has shown the slightest sign of setting foot there. The staircase lays out the problem nicely. Somewhere on those steps there is one that almost nobody climbs, and the odds of climbing that one sit right up against 0. Only one question really matters. Is it behind us or ahead of us? Let me start with the good hypothesis. Simple life showed up here far too fast, almost the moment the oceans cooled. Or rather, the moment an ocean could exist at all, there were already bacteria swimming around in it. Then evolution jammed. For nearly 2 billion years, the Earth was a planet coated in slime, made of single cells. 2 billion years of standing still. What unjammed it was a random, unlikely accident. One bacterium swallowed another and failed to digest it, and the two carried on living together. The one that got swallowed became the mitochondrion, the part that manufactures energy inside every cell of your body while you listen to this. The biologist who made the case for that explanation was Lynn Margulis in 1967, in a paper turned down by about 15 journals before somebody agreed to run it. Today, it sits in every school biology textbook. If the filter is that meeting between two bacteria, we can breathe. It would mean the universe is full of slime and empty of conversation, and that we walked through the impossible part without noticing. Except there is a way to test that, and the test is cruel. In 2008, the philosopher Nick Bostrom of Oxford published a piece in an American technology magazine laying out a rule that runs backwards. The more life we find in space, the worse for us. If a probe finds living bacteria under the ice of Mars tomorrow, the whole planet will celebrate, and it ought to be terrified. If life started on its own twice in the same neighborhood, then its beginning is a cheap trick, and the impossible step is not back there. If instead of bacteria, a fossil of some complex creature turns up in the ocean of Europa, the frozen moon of Jupiter, the news gets worse. And if one day Somebody digs up the ruins of a city on another world, built by people who got as far as we have and then vanished, then there is no doubt left at all about where the filter lives. It would live right in front of us. What would have the power to bring down 100% of civilizations? Nuclear war does not. It would kill almost everybody and throw the rest back into the Stone Age. But a handful of survivors rebuild a population in a few thousand years. Anybody betting on the bomb as the end of the line can settle in and wait. Asteroids and gamma-ray bursts do not do the job either, because a grown-up civilization sees those coming decades ahead and steers out of the way. The filter has to be something a civilization manufactures itself, and manufactures precisely when it gets good enough to feel safe. A virus assembled in a lab with a year of silent incubation and total lethality would contaminate the entire planet before the first symptoms showed up in anybody. And the price of synthesizing a genetic sequence drops every year, while the number of people with access to the equipment climbs at the same speed. Eric Drexler described a second route in 1986, microscopic machines that copy themselves out of whatever carbon they find in front of them, and that through one faulty instruction would start eating forest, animal and person, without telling one from the other. This whole conversation rests on an assumption nobody has checked properly. We keep assuming they died. Nobody has looked at the simpler possibility, which is that they are alive and do not want to talk to us. Alive and quiet. That possibility has had a scientific name since 1973, and the fastest way to get your head around it is to step away from astronomy and go walk a trail through thick brush. You are heading down the trail, listening to the birds, and you stop because you almost put your foot in an anthill. There is a whole city down there. Thousands of workers hauling leaves, tunnels dug out, the queen protected deep inside. You stand there looking for a minute. At no point does it cross your mind to open diplomatic negotiations with them. Nobody kneels down to explain to an ant how a fusion reactor works or offers her a trade deal, leaves for sugar. You looked, you thought it was beautiful. You moved your foot aside so as not to wreck the mound, and you went on your way. That is more or less what John Ball, a radio astronomer at Haystack Observatory, proposed in that paper from '73. He called it the zoo hypothesis. The idea is that there are people out there, that those people know we exist, and that they have decided not to interfere. Earth would sit inside an exclusion zone, and silence would be the standard protocol every civilization follows. The question everybody asks straight away is why they do not come and take what Earth has plenty of, which is water, metal, and a decent climate. I threw that part at Axiom, and the result is the opposite of what the movies taught us through science fiction. Water is one of the most common substances in the universe, and there are billions of comets made of nearly pure ice drifting around with nobody's name on them. Gold and platinum sit loose in the asteroid belt of any dead system, with no gravity holding on to them and nobody nearby to complain. Coming down a gravity well like Earth's to mine here would run thousands of times more expensive than scraping an empty rock 3 systems away. Matter they have to spare. The one rare thing is an evolutionary line running on its own from the start with nobody meddling. That is not something the universe manufactures. And look, to find out what happens when somebody does meddle, you do not have to leave the planet. Every time a technologically advanced people has touched a less advanced one, the second one disappeared. Through disease, through shock, or through both at once. In the Bay of Bengal, there's an island called North Sentinel, with a handful of people who have lived there for tens of thousands of years, who use no metal and who fire arrows at any boat or helicopter that comes close. The Indian government does not send in troops and does not try to talk anybody into anything. It banned going near, end of story. We watch from a distance and leave them alone because we learned that the alternative kills. Anybody who watches Star Trek has seen that rule at work under another name. Gene Roddenberry wrote the prime directive into the series, forbidding the fleet from meddling in worlds that have not yet found interstellar travel, and turned it into the moral dilemma of half the episodes. It was a nerd punchline for decades. Today, it gets cited with a straight face in astrobiology debates because nobody has come up with a better rule. If there is a fence like that around the solar system, whoever is minding it would not be using flying saucers. They would use a sensor the size of a speck of dust scattered through the atmosphere, invisible to any instrument we own. In 2001, the British physicist Stephen Baxter went further in a paper for the Journal of the British Interplanetary Society and suggested that even the empty sky could be staged, a projection set up all around us. It is a fun idea to hear and impossible to test. So I am setting it aside because the zoo hypothesis has a far more concrete problem. It demands unanimity. For a quarantine to hold for millions of years, every civilization in the galaxy has to agree and stick to it. Without a single exception, there can be no splinter group, no smuggler, no bored researcher willing to fire a signal at Earth just to see what happens. One is enough. The odds of billions of worlds that have never spoken to each other, keeping a perfect agreement for millions of years, without one defection, press up against zero from the inside. We, by the way, have been lighting fires and waving our arms for decades, and nobody has answered even to tell us to shut up. That is the same sum Enrico Fermi ran in his head in the cafeteria before asking, "Where is everybody?" If the explanation is not good manners, one possibility is left over that nobody raised at that table that day. Nobody answers because answering is dangerous, and it kills. Answering kills because the forest is crowded, and everyone inside it knows that. The image comes from the Chinese writer Liu Cixin, who built a whole trilogy on top of it, starting with the three-body problem, and the explanation shows up in the second volume. Netflix adapted it in 2024, and the show went viral for a few weeks, which is rare for an idea out of cosmic sociology. The forest is dark, and there is no clearing. Between the trees, there are armed hunters moving slowly, and every one of them knows the others are in there. None of them can see anybody's face. If one steps on a twig and the twig snaps, he dies that same second, because whoever heard it has no way of working out whether that is a fellow who wants to share his food or a fellow who wants to cut his throat. The only safe play is to shoot first at any noise. Liu Cixin rests all of that on two short axioms. First, every civilization wants to go on existing, and that comes before any religion, philosophy, or morality it happens to hold. Second, every civilization grows, but the matter and the energy in the universe are a fixed quantity. With both of those holding at once, sooner or later, two of them are going to want the same thing. Even so, you would still have to explain why they cannot simply talk it over and share. Two pieces are missing, and both of them are uncomfortable for us. The first he called the chain of suspicion. Say we find a civilization 10 light years from here, and that, by absurd luck, we know they are peaceful. Can we open up and try to make contact? We know that we are friendly, but they do not know that we know. We send a message swearing peace, and they have no way of telling a sincere oath from bait in a trap. They might believe us. We have no way of knowing they believed us, and if they conclude that we are lying, they will strike first. And then we need to strike first before they strike first. The spiral never closes because there is no judge, there is no police, and the message takes 10 years to go and 10 to come back. Any trust costs far too much to test. The second piece is worse, and it is the one that settles why nobody spares a backward civilization. Technology does not grow in a straight line. Our species is about 300,000 years old, invented firearms 1,000 years ago, radio a little over 100, and between the Wright brothers' first flight and a robot walking on Mars less than a century went by. Light is slow too. If somebody is watching us from 1,000 light years away, they are looking at an earth of castles and swords, and they know perfectly well the image is old. There is no way to bet on what is here today. You do not sit around waiting for the tiger cub to grow up to see how it turns out. At that point, the calculation changes in kind. The target stops being an enemy and becomes a risk to clear away while it is still easy and cheap. The blow would not be a fleet arriving with music underneath it. All it would take is a piece of metal the size of a refrigerator, accelerated to nearly the speed of light. Nobody sees it because the light bouncing off it arrives at the same moment it does. No alarm, no time to react. If it hits the sun, the energy of the impact destabilizes the star, and the plasma that comes off boils the ocean and melts the crust inside a few hours. The energy cost of that, for somebody who commands an entire star, is about the same as flicking a lit cigarette butt into an anthill. And what has humanity been up to with that rule in force? In 1974, from the Arecibo radio telescope in Puerto Rico, Frank Drake and Carl Sagan fired 1,679 bits in the direction of the Messier 13 cluster in the constellation Hercules. The message carried a bit of mathematics, the formula of our deoxyribonucleic acid molecule, a drawing of the solar system, and the exact position of Earth inside it. 3 years later, the two Voyager probes went out carrying a golden record with a map of 14 pulsars, which lets anybody with basic geometry work out where our sun is. We walked to the edge of the woods, lit a bonfire the size of a building, and shouted out our address. It has been burning for 100 years, and our radio light has already swept past thousands of systems. If the dark forest is right, something has already heard the snap. Except here, the logic seems not to add up. If it heard, why are we still here? Maybe we are still here because there is nobody listening. That is the gentlest explanation of the lot, and for some reason, the one the fewest people entertain. In the year 2000, the paleontologist Peter Ward and the astronomer Donald Brownlee, both at the University of Washington, published a book arguing that simple life should be common in the universe, and complex life almost impossible. It became known as the rare earth hypothesis. Their argument is a list of coincidences. Not one of them is impressive on its own. Stacked one on top of another, they start to get frightening. The first coincidence is the address. Near the center of the galaxy, there are too many stars crammed together and too much radiation, and no delicate chemistry lasts long in there. Out at the rim, there is no iron and no silicon. The heavy stuff that only exists because old stars died and scattered material around. We happen to end up in a narrow band between those two problems of existing. Then there is the sun. Close to 70% of the stars in the universe are red dwarfs, small and cold, and to soak up enough heat from one of them, a planet has to orbit so tight that it locks. One side faces the star forever, boiling without a break. The other goes through a night that never ends. A red dwarf also throws off plasma flares that strip the atmosphere off a neighboring world the way you blow dust off a table. Our sun is a yellow dwarf, a minority type, famously dull and steady for billions of years. Here comes Jupiter, and this is where the story needs fixing. For decades, we were taught that Jupiter is our doorman, that its mass pulls comets in and shields us from bombardment. Jonathan Horner and Barry Jones of the Open University in Britain ran simulations published between 2008 and 2010, and the result came out a lot messier than what we know. Depending on the mass you give Jupiter, it deflects dangerous bodies, and depending on the mass, it shoves dangerous bodies inward. Let me correct that. It does both at the same time, and the balance is a fine calculation nobody has settled to this day. Our doorman sometimes waves in the ones who should have been kept out. The moon. Now, that is pure luck. Having a satellite that size going around a small rocky planet is a mechanical anomaly. It was born out of a collision, some 4.5 billion years ago, between the young Earth and a body the size of Mars, and the material that splashed out gathered together up there. Without that hit, the axis of our planet would wobble over millions of years, and a climate doing somersaults produces neither seasons nor agriculture. And there is the core. The middle of the Earth is liquid metal in motion, and that motion generates the magnetic field that turns the solar wind aside. Mars had an atmosphere, lost its field, and the solar wind carried the air away. You have seen what was left of it in photographs. The tectonic plates go into the same account, the ones we file under earthquakes and disaster, but which work as the planet's thermostat, recycling carbon and holding the temperature inside a narrow band for whole ages. I handed the entire list to Axiom to multiply out. Each factor on its own has a small chance, and multiplying small things together shrinks fast. The number that came back was so low that even with 2 trillion galaxies in the sum, there may not be enough planets in the observable universe for the combination to come up a second time. If that is it, the silence is nothing special. There is no hunter in the forest and no fence around the solar system. There is bacterial slime on billions of worlds and nothing else. And we are the accident that climbed the staircase to the 8th step while all the rest stayed put on the 3rd. It is an explanation that almost comes as a relief, and it also makes everything sadder. There would be nobody to talk to and no manual written by anybody who has already been through what we are about to go through. That sum has a hole in it, and the hole is recorded in the data from our own telescopes. Because if the universe is that dead, somebody has to explain why there is a star in the constellation Cygnus that spent 2 years going dark and lighting up again in a way that no rock, no planet, and no dust we know of should be able to manage. That star in Cygnus sits 1,500 light years from here and has a long catalog number where a name should be. It became known as Tabby's star after the astronomer Tabitha Boyajian, who led the study in 2015. The Kepler telescope caught its brightness dropping by 22%, with no fixed period, no regularity whatsoever. The size of that becomes clear in a simple comparison. If Jupiter passed in front of the Sun seen from outside, the drop would be 1%. 22% means something covering nearly a quarter of a star. It was the first time professional astronomers discussed a megastructure in public without laughing. The idea is old. In 1960, Freeman Dyson wrote that any growing civilization eventually runs into a shortage of energy, and that the only abundant source in a system is the star itself. A planet makes use of a ridiculous fraction of what the star spits out. Dyson pictured a cloud of collectors in orbit, put together little by little, catching what goes to waste today. It became known as the Dyson sphere, though he explained later that what he had in mind was a swarm of separate pieces. The hunt for those structures has produced, across decades of infrared sweeps, exactly nothing. His 0 confirmed candidates. Then Tabby's star turned up, and for 2 years, it was the best lead anybody had ever had. It did not last. Juan Meng of the University of Arizona published in 2017 The Measurement That Settled the Question. The star dims more in the ultraviolet than in the infrared. A solid object blocks every color equally. Dust does not. Boyajian confirmed it the following year, with observations from Las Cumbres Observatory paid for by some 1,700 people chipping in online, which is a lovely detail about how science sometimes happens. It was fine dust, grains smaller than a micron. Or rather, it was dust. And that is exactly why the news is bad. The best lead we ever had came to nothing, and we are back to absolute zero candidates. There is a more uncomfortable reading of this whole story, and it is about what we decided to go looking for. Robert Bradbury developed the concept of the Matryoshka brain, layers of structure wrapped around a star, each layer using the heat thrown off by the one before it, one inside the other. The consequence is that a civilization like that would not glow in the infrared, because heat thrown away is energy lost, and nobody who commands an entire star wastes the last drop of it. We are hunting for the smoke trail of a badly built campfire. Whoever got there makes no smoke. And then there is the deafness, which is the most embarrassing problem of all. Since 1960, we've been pointing antennas at the sky hoping to catch radio. In Contact, that film from 1997, Jodie Foster spends half the story sitting in the desert with a headphone in her ear, waiting for a signal to come in from space. That is how an entire generation pictured First Contact. The trouble is that radio travels at the speed of light, and the Milky Way is 100,000 light years from end to end. Sending a question from one edge and getting an answer back from the other takes 200,000 years. Nobody runs an empire, a trade route, or an alliance on that kind of delay. For a conversation between stars, radio is a carrier pigeon, so what is left? Neutrinos go through an entire planet without being nudged off course, and in 2012, a team at the Fermi National Accelerator Laboratory actually transmitted the word neutrino through 800 feet of rock. It works. Gravitational waves, which the detectors of the Laser Interferometer Gravitational Wave Observatory picked up for the first time in September 2015, also carry information and pass straight through any obstacle. And here I need to correct an idea that gets around a lot. Quantum entanglement is no good for sending a message. Physics forbids it, and the ban has a name: the no communication theorem. Nobody gets a shortcut. Not even them. Which means distance still applies to everybody. And so does time. Our own campfire's going out on its own already because open broadcasting has turned into cable, fiber, and tight satellite beams. We are going quiet without having decided anything. That changes the whole question. What if nobody is hiding, and the problem is when each of us shows up? When each of us shows up is the answer. And it is simpler than hunters, fences, or a statistical miracle. I passed the entire set to Axiom, and the verdict came back short. We are not alone. The galaxy is far too big and the chemical elements far too common for Earth to be the only place where it worked out. Life lights up in plenty of places. The problem is that it lights up and burns out at different times. And two fires almost never overlap. Look at the size of our own window. Humanity has been broadcasting on radio for about 100 years and is already turning the volume down on its own. Be generous, and that gives you 200 years of noise. In a galaxy 13 billion years old, 200 years is less than a blink. Two civilizations can be born on neighboring stars, one 1,000 years from the other on the clock of evolution, and never hear each other. One shouts while the other is still bacteria, and by the time that second one finally learns to shout, The first one has long since fallen silent. So, we are not looking in the wrong place. We are looking at the wrong time, trying to spot a struck match from the other side of a dark continent, on a night when almost every match has already burned out. There are only two ways for that window to close. The first is to die. The second is to change your nature and drop out of sight. John Smart called the second route the transcension hypothesis, with civilizations that stop growing outward and start growing inward, shrinking, getting denser and faster, until they stop giving off anything we know how to measure. Some have suggested black holes would be the final destination of all that shrinking. It is a fun idea. There is no way to test it, and I am moving on. What we can test is the first route, because we are inside it right now. Our species built in the space of 80 years a weapon that can flatten a continent. It learned to edit the genetic code of any living organism, its own included, and the cost of doing that falls every year. Now it is building, in a hurry and with money behind it, machines that think. Not one of those three things existed when my grandfather was born. The third one is worth stopping on. Biology is slow, fragile, and expensive. A human body takes 20 years to be ready, dies easily, needs sleep, and does not work outside a narrow band of temperature. A built intelligence needs no air, does not feel radiation, and can copy itself. If the machine reaches real autonomy, the body of flesh becomes the scaffolding you take away once the building stands up on its own. Not out of hatred, because hatred takes hormones. Out of arithmetic. The great filter may be exactly that moment, when a species turns powerful enough to wipe itself out before it turns mature enough not to want to. On the 27th of January 2026, the Bulletin of the Atomic Scientists moved the doomsday clock to 85 seconds to midnight. It is the closest to the end the clock has stood in 79 years of existence. They named nuclear weapons, climate, biology, and artificial intelligence in the same sentence. The people signing that off are a committee of physicists with 8 Nobel winners among their advisors, looking at the same world you see out of your window. We are on the 8th step of the staircase with 1 foot in the air. The place where that foot comes down does not exist yet. If it comes down wrong, the graveyard gains 1 more headstone, and that one will carry our name worn away by time until there is no name on it at all. The antennas fall silent, the cities turn into dust with radios buried in it, and the 200-year campfire we lit at the edge of the woods goes out without anybody ever getting close enough to see the light. 1,000,000 years from now, in another arm of the galaxy, some creature will step out of where it lives on a clear night, far from the lights of its own city, and it will count the stars it can see with no instrument at all. It will run the same sum we ran, with the same numbers, and it will arrive at the same astonishment and the same emptiness. And it will ask, "Where is everybody?" without knowing that it is looking straight in the direction of our grave. If you liked this investigation, subscribing to the channel helps us expand the Axiom Investigation project. We would love to read your thoughts on the video's subject in the comments and your suggestion for the next topic to be covered. Tell us which city you are watching from. Thank you for staying with us until the end.